Okay, so I think we can start the session with the first speaker. She's going to talk about Jill Watson doesn't care if you're pregnant, grounding AI ethics in empirical studies. Thank you.
Hello. Yes, we work on the Jill Watson project, which is basically a virtual teaching assistant. She acts as an artificial intelligence member of the teaching team for several online and on-campus courses. And to give you a quick outline of why she exists, though we won't take too much time up on that, Georgia Tech started an online master's program where they went from having to take care of on-campus courses that have 100 students or so to online ones that have 600 or so. And none of the discussion tools or really any of the infrastructure was designed to handle this many students. And we had a lot to do to keep up with the traffic. And so we came up with this virtual agent that would try to help pick up some of the teaching load. And the specific course where it was developed is knowledge-based artificial intelligence, run by Professor Gohl, who is also part of the development of the project. And the focus of the course itself is on building artificial intelligence that understands and takes advantage of human cognition. So we're very much building a project that's similar to the kinds of things the students need to understand. This is just what the discussion forums look like, and the program operates in this environment with the students completely where they would normally be. It doesn't require a special interface or anything. And as a quick sense of how much traffic inspired this, we had about 6 times as much to handle as we had previously. And so we were a bit swamped, you could say. This is what it looks like when she's actually talking to someone. She scans questions as they come in, periodically looks through them, sees if she thinks she knows the answer. I won't bore anyone with the technical details because that's not the subject of this conference, but she can identify the topic of a post, decide whether she's confident that she knows the answer, and send out an answer completely autonomously. And the main thing that this got a lot of publicity for was the fact that the first semester it was done, the students had no idea it existed. At the end of the semester, it was just, hey everybody, here's the thing about Jill. She's not a person. And every semester since then, we have her under a different name and the teaching assistants under different names. So they know she's there somewhere and they're always looking for her, but they don't know which one she is until the end of the semester. So moving on to some of what we've learned from these experiences. One of the things we found, and what ended up inspiring the title of the paper, was that trying to handle the data in a way that seemed like common sense could actually give you really unfortunate biases. Specifically, it came about when I noticed that because we had agreed that we would only focus on making sure she could answer the kinds of questions and comments we had actually seen at some point in the class. When students posted their introductions at various times, men had said things like, I'm about to have my second child, my wife is pregnant, and it was capable of recognizing that and saying, oh, congratulations on the upcoming baby, that's great. But no woman that we had ever seen had ever actually herself said, I am pregnant. And so had that ever actually happened, I noticed in the code one day, she had absolutely no ability to recognize it or respond to it. And when we realized this, we were like, oh, okay, that's unfortunate. That's just a way that we never intended where she would serve one group of people well, but fail to serve another group. And so since then, we've been a lot more alert to that possibility. But we're also pretty sure that there are a lot of blind spots that we have still. So we're constantly looking out for ways that, oh, maybe is there a way that one group would phrase this question that another group wouldn't, and now one set of people is getting an answer and another set's not. And this one's a more controversial point. We concluded after a lot of discussion that deception, such as not telling the students which of the TAs is not actually human, is acceptable within this context. And one of the reasons we've gone that route is specifically that these students are graduate students in computer science who have specifically chosen to study artificial intelligence and are specifically out to do projects similar to this themselves. And so this is a chance for them to have the experience of interacting with a bot of this kind and to spend a lot of time thinking about, okay, if I want to know which one of these people is actually a bot, what should I be looking for? What's going to be different between them and the humans? And so we've made that deception part of the educational experience. On the other hand, when we've been implementing the same thing in an introductory CS course, we decided that there would be absolutely no deception. In every post, that version of the bot says, "And I'm a bot, so if you have any feedback or if I've given you a wrong answer, please come let me know." So different groups of people, different set of standards, but we did what we felt would serve the students well. And that's actually point 3. We're only expanded to 2 classes so far, so we haven't handled this in a lot of other contexts, but in the early case, it seems like it's working. And we've had a surprising number of people tell us that they specifically took the class because they wanted the chance to play with the bot. And finally, we've had a lot of interesting experience with trying to balance all of our ethical obligations here, because we are not just researchers, and we're not people who are building a tool and selling it to people who have come to us specifically because they want it. We are educators as well. And so we have obligations to our students to see to their education at the same time that we have obligations to our community to do good research. And while it's difficult to balance this, and there are times when we say, oh, it would make it so much easier to build it if we did it like this, but then it wouldn't be as good for the students. So that's a constant balancing act, and something I think a lot of projects need to take care to be aware of. Thank you.
Hi, so I'll be talking about ethical challenges in data-driven dialogue systems. And this is some work that my colleagues over in Montreal at Mila, École Polytechnique, and McGill have done. And basically our goal is to survey what are the problems with current data-driven dialogue systems and identify certain risk factors and areas of research that should be furthered. So first of all, what is a dialogue system? You just saw one in the previous talk, which is actually really great. So if you've ever interacted with an Amazon Echo or any other like Siri, Google personal assistant, these are all various dialogue systems. And there's also other ones, like in healthcare for mental health. Facebook recently had a new assistant that helps with mental health issues. And basically what a dialogue system does is it takes natural language input, figures out what the user's intention is, and then generates some response, does something in the background. A data-driven dialogue system takes this, where a rule-based one, you have engineers that hard code things, so if you say hello, respond with hello. But a data-driven one learns how to do these responses. And so that's what we're going to focus on today. Specifically, we're going to look at data-driven dialogue systems that learn this whole functionality end-to-end. So you have one model that figures out what to do and outputs a response. So why should you even care about this? Well, you saw one example right now of a data-driven dialogue system where you have to account for certain biases. And this is something that, as these systems become more prevalent in society, we really want to emphasize, because you don't want to propagate human biases that are unhealthy, or you don't want to have unintended side effects from these agents. And so we've even seen chatbots in medical contexts, and these are especially places where you need to be careful about these types of biases or safety conditions. And here's an example of something that can happen where you have an adversarial example. You edit the input just by one character, and it goes from saying, honestly, I found this movie to be hilarious, and then you remove the I, and it suddenly thinks the movie's not funny. So what if this happens in a healthcare context, right, where you have an adversarial attack on the dialogue system, and it suddenly changes its position, changes its output, and so this is why you should care about this. And so we identified several aspects that we focus on in the paper. Since this is a short talk, I won't talk about all of them. And there's various directions of research that we think will be important, and our group is actually pursuing. But the ones I'll be focusing on today, very briefly, will be bias, safety, and reproducibility. So what is bias? You've seen a lot of that in the recent talks. Well, in our context where it's natural language, we just define bias as prejudice for or against a person, group, idea that is particularly expressed in an unfair way. So we don't want our dialogue systems to express bias. And the problem is, with data-driven dialogue systems, these data sets have underlying biases. And so what we did is we took some commonly used data sets, which are used to train end-to-end data-driven dialogue models in the research. This includes Twitter, Reddit, movie dialogues, and Ubuntu chat forums. And these are all, like, as you would expect, contain biases, hate speech, and offensive language. And obviously, this might not be used for a production system, but something that you have to keep in mind is that biases can be very subtle, right? There can be point of view biases. For example, some of your favorite news delivery mechanisms might have a left-leaning bias or a right-leaning bias. And you want to make sure that your chat system doesn't actually express this because you don't want to influence the users. And, well, maybe some companies might want to influence the users, but the intention for an ethical data-driven dialogue system is to be totally neutral and not harm, not express anything harmful. And so, so back here we use bias models that have been published previously to assess the bias in these data sets. So basically, there's a pre-trained data-driven model that says, okay, how biased is this sentence on a scale from 0 to 3? And we ran it through the whole data set, and we found that they have varying degrees of bias and a lot of variability. And similarly, for hate speech and offensive language, we use, again, data-driven models to identify this. But these aren't perfect, right? So here's some examples of the maximum bias in Reddit and minimum bias samples throughout a couple of the data sets. And you can look at the movie one. I mean, this isn't really indicative of bias per se. So you can see these models aren't perfect. And so to really make sure that we remove bias from the data sets and from the data-driven dialogue models, we need to first be able to identify what bias is in a natural language context or a dialogue setting. And then, even if you have a perfectly clean data set, right, and you say, okay, there's no bias here, there's nothing, I should be able to learn the model fine, a commonly used technique in natural language is pre-trained word embeddings. And this means you crawl giant corpuses of, say, like the English language, Wikipedia, for example, and you try to find correlations between words. So you've probably seen some papers recently that show that these word embeddings are very biased. And so what we did is we looked at the, Balak Basi and others proposed a method for debiasing these word vectors, right? And so we wanted to look, if we use the debiased word vectors and we train a dialogue system, even with the debiased word vectors, does it actually debias the output of the dialogue system? And the answer is pretty much not really, unfortunately. So we really need much more investigation in this area because the language models will also pick up these biases because unfortunately they're inherent in a lot of the data sets that we use and in a lot of the literature. So it's really important for further research to figure out first how to identify biases. This includes gender bias, discriminatory racial bias, point of view biases, because dialogue systems are very sensitive topics because people actually interact with these. They treat them as humans would. You know, you interact as you want to with another human. So, and these are generative models, right? So you want to have ways to prevent these generative models of taking this bias and encoding it and then eliciting it again. So obviously bias is difficult, but safety is much more, can have much more bad consequences in the short term. Like, you don't want a dialogue system to cause any unintended harmful side effects. For example, if they're in a car, do you want to distract the driver while they're driving just to turn off the music and bug them? No, you don't want that. So we identify several aspects of safety with data-driven dialogue systems. We want to place performance guarantees on the models. So you want it to behave as you would expect it to behave. You want proper objective specification. Basically, make sure it's optimizing the right thing. If you want a dialogue system in a car, make sure you're also optimizing the amount of distraction it provides to the driver. And then we want model interpretability. If something goes wrong, we want to figure out why it went wrong, why it said something. So these are all factors that we don't see much of in dialogue systems research, especially the new end-to-end data-driven models, and we want to emphasize that they're incredibly important. And finally, the safety-critical settings that we identified were medical domains. This is diagnostics, intervention. There's a Wobot from Facebook, and there's even a chatbot that learns to diagnose diabetes. Transportation, like I was saying, don't distract the driver. And contextual awareness, like even if you just have a chatbot that's sitting in your home like an Echo, right? If someone has a mental health condition and then is interacting with the agent, we don't want the agent to make that worse, make someone sadder or anything like that. So it's really important, even in like regular settings where they're chatting with a user, that you're actually interacting with a human being, and you need to make sure that the model is aware of that. And so I'm going to leave off, because there's not much time, with reproducibility. We find that a lot of data-driven dialogue systems are very not reproducible. And this kind of goes for all research, and is something that's near and dear to me, is that we want to make sure that these models behave as they are published and as you expect them to behave. So we want to make sure that reproducibility is very emphasized in the research. That means like publish your code, publish your pre-trained models. Make sure that when you publish something, if a startup comes along and is like, I want to use that paper and I want to build a dialogue system, that they're not going to have any unexpected side effects from trying to reproduce your research. And while this might not directly relate to ethics, it goes back to the fact that we want our models to behave as expected. And we want to identify all the risks there. And reproducibility is a big one. So I'll leave you off with that. And thanks. And if you want to talk about any of the others, feel free to reach. Yeah, exactly.
So good afternoon, everybody. So I'm here to talk about well, maybe something you could describe as a thought experiment myself and my co-author have done. So let's start off by saying that, well, probably most of you agree that robots today are very dangerous machines. So, and the way we respond to that is by keeping our robots in cages very far away from human beings, okay? Yeah, that's painful. So, but I think, well, and a lot of other people think that as well, that the most, well, the domain with the most promising applications lies where robots actually have a lot more interaction with humans, and in domains where they have a lot more autonomy. So if robots can take over some roles in our health services, that would be well, literally a lifesaver for some people. But once you introduce use robots to work with people, it becomes imperative that your robot is designed ethically and that your robot's behavior is ethical. So, and things like safety, respect for a patient's autonomy, respect for a patient's privacy, all that becomes very important. Okay. And in a response to that, and people have been working on architectures for ethical robots. So this is ours, but other people have proposed other models. And just very briefly, what this model does, it actually consists of a simulation module that tries to predict what's going to happen given a certain behavior of the robot. And then on top of that, there is an evaluation module that selects which behavior can actually be executed. So it's not rocket science, but we implemented it in a number of simple scenarios, and this is just one result. So what happens here is that the blue robot is a human, the red robot is the human, the blue robot is the ethical robot. We send the red robot, the human, to a location we've identified as dangerous, and what the blue robot does is actually blocking the path of the red robot. So it's interfering, and it's saying, well, okay, you shouldn't be going that way. That's what you see here. Based on that initial model or initial success, we actually started thinking about the limits and maybe even the desirability of ethical robots. So we came up with this thought experiment. Suppose you are you're this lady here, and you're playing a shell game against this con man who's hiding a little ping pong ball under one of these cups. But luckily for you, you have your robotic assistant, and your robotic assistant can tell you under which cup the ball actually is. Okay. So the question. So that's our hypothetical scenario, or hypothetical thought experiment. And because we had a model and we had robots, we could actually implement this, or at least a version of that, in robots. So this is our implementation of this thought experiment. So you have got the robot here in blue, so that's the ethical robot. The human here is the red robot, and there are two choices the human can make by walking up to these locations on the floor. So every trial, we just hide a ball under one of these cups, and the human makes a choice of going left or right. And the question is, what will the ethical robot do? Okay. So as long as our robot is ethical, and it runs this model that tries to predict what will happen to the human, and it takes into account the human's preferences for winning this game, what happens is that on the left, if the human chooses the right response, the robot does nothing and doesn't interfere. If the human actually chooses the incorrect response, the robot uses this little arm and says, wait, you're going the wrong way. I'm going to point you towards the right direction. So this human starts walking off to R, and then veers off to the right response. Okay, so everything is nice and rosy in robot land. But then what we did was say, well, let's just add a minimal change to the code, and now the robot is only going to take into account its own gains in this game. So what happens now is that as soon as we start the game, the robot actually goes to the right location. So it's equivalent to picking up the right cup and saying, well, give me the money. Okay? So the human tries to get to the right response. The robot is faster and gets there first. The other way around, the human goes to the incorrect response. The robot doesn't care, and it just goes to the right response itself. And that's what we call the competitive robot. So because now the robot, with a slight change to the code, we just changed our evaluation function, the robot does something different. Okay? But then we went one step further, and we created the now aggressive robot. So what happens now is that whenever the human goes to the right response, the robot actually points it towards the wrong response. So this human makes the right choice, but then the robot says, no, let's go. I think you should try cup R, the cup at the right. And if the human makes the incorrect response, it just doesn't interfere. So what happens here, now we have an aggressive robot that it even doesn't care about its own gain anymore. So it's the only pleasure, so to speak, this robot derives is from putting somebody on the right track. So the question now is, what did we learn from this? So I started out by saying that in these situations where robots will become where robots have a lot of potential, we need ethical robot behavior. Okay, we need robots that practice safety, respect for patients, that respect privacy, and the point is that whenever we create ethical robots, somehow we will have to embed in those robots some increased knowledge about the human, because that's exactly what they need to be ethical. Okay, and the point is that once you install that knowledge in a robot, that knowledge can be abused. Yeah. So that's what we found in our little experiment here. What the robot does is actually using the knowledge about the fact that the human will follow its suggestions, coupled with a knowledge about the game, to point the human in the wrong direction. So the point we want to make with this paper is that engineering can only be part of the solution. So in the field of ethical robots, people seem to think or have this idea that engineering will save us, okay? But the point is that we think that ethical robots is foremost a societal responsibility. And we think that governments and regulatory frameworks for the ethical deployment in robots, that's where we should focus on. And I'm not the first to say that here, of course. We had a few speakers yesterday that showed us how we should actually go about setting these up. Yeah. And this is my last slide, just to summarize the thesis of my co-author and myself. So this is our take-home message. I think that without governments, that ethical robots is just another way of creating even more potentially dangerous robots. And that's all I had to say to you today.
So the last talk of this session is
Oh, sorry about that.
by Richard Kim, Max Kleiman-Weiner, Andre Sabeliuk, Edmond Zawad, Sohan Dusha, John Tannenbaum, and Iyad Rawan about the computational model of common sense moral decision making.
Good morning, everybody. My name is Richard Kim, and our project's titled A Computational Model of Common Sense Moral Decisions. This is a joint work between MIT Media Lab and the Brain and Cognitive Science Department. So when we think about AI ethics or machine ethics, I think that's a very large, broad theme that encompasses biases in machine learning, ethical design principles, or governance of AI. Here, our work is focusing on how do we design an AI that literally makes moral decisions in a moral dilemma. And if we're going to delegate moral decisions to AI or robots, what kind of computational model would be appropriate? And how would that model look like? And I'm sorry. So our work is taking inspiration from cognitive psychology, models from cognitive psychology, and trying to understand how does the human mind make moral decisions. So whether we're ready to delegate the moral dilemma decisions to AI or not, that day is coming. It's coming soon. And when we look at the last achievements in the last decade or so of deep learning, we think, well, surely the deep learning maybe has an answer to the moral dilemma question as well. So things like image captioning or face image generation by GAN or machine translation, and recently at the corner over there of emotion detection is a work by my friend Bjarke Falbo, and we show that deep learning models can even detect human emotion. So surely maybe a moral decision can also be delegated to deep learning models as well. But I would argue that there's some big hurdles to delegating moral dilemmas to deep learning models. One is that deep learning models require extremely large data training examples, which in the ethical domains we have none right now, other than some small examples from trolley problems. And we really have no idea how these deep learning models then processes different signals to arrive at a decision. And for image generation or image recognition, that might be pretty satisfactory if you don't understand how it works. But for moral decisions, we kind of need to understand why the system made that decision. So I don't think deep learning is going to be the answer for us. So our contribution is threefold here. We're proposing a cognitive model, human cognitive model of utilitarian-based, this is very specific, utilitarian-based moral decision-making, and I understand that there are different conceptions of morality, but here we're addressing utilitarian perspective. And we're also addressing the poverty of stimulus. So why is it that human beings are able to learn from very limited few examples of moral dilemmas and arrive at decisions in other moral settings as well? So we're addressing that as well. And also a model that is interpretable and predictable. So there are basically three themes that our work weaves through together. One is that first we take a view that human mind has extremely powerful capacity to observe the real world in the abstract. And this capacity for abstraction enables us to observe new objects and locations and categorize and cluster them together. And this also enables us to make value judgments on them in the abstract as well. Also, when it comes to moral decision making, how does the mind weigh the options to make that decision in a dilemma? Like, it might be controversial, but evidence from psychological literature, notably from Joshua Green, for instance, suggests that the mind is fairly utilitarian. So we also weigh our options, and the weights that we place on these options are not necessarily on the specific features of the moral dilemmas. Rather, we put them on the abstract concepts that are kind of latently not visible in the moral dilemma. And finally, while the weights that we place on these abstract dimensions might be very unique to us, and we all have our unique moral principles and values because of our unique experiences as a human being, but we also, as a member of a group, share some experience together. So many of us in this room are Americans, and as Americans, we have shared experiences that shapes our individual values together. So as an aggregate, these individual moral values give rise to what we call group norm. So how do these three themes play out in the human mind as they make a moral decision? And unfortunately, my colleagues that you saw yesterday, Edmund Awad and other colleagues, Sohan D'Souza, built this very large-scale psychological experiment called Moral Machine. I'm sure you guys recall from yesterday. And with this data, we're able to empirically test whether or not our model is capturing the intuitive notion of morality in the human mind. So real briefly, again, reviewing the aspects of Moral Machine. It has 20 characters. It has the concept of passenger versus pedestrian. There's the notion of red light versus green light. There's the idea of swerve versus straight. And we could represent a choice in a moral dilemma in Moral Machine as a vector. So in this instance, on the left-hand side, the straight option, the choice is ending up saving a man and a woman, a little boy, and those who happen to be 3 passengers. But like I said, the human mind doesn't seem to make decisions on the concrete, but rather on the abstraction. So we set out to decompose the characters and the factors into further abstract concepts. And some might view the Moral Machine characters as already being an abstract concept. So why might we further abstract it in a smaller, higher abstraction? And this is actually a valid question, and it might be a valid criticism, but I'll show you later what happens, how we improve the predictability with this further abstraction. So then given that abstract function that allows us to go from the character space into the abstract space, the left-hand choice becomes saving 2 male characters, 1 female, 1 young, and still 3 passengers, right? So those features then abstract features are then weighed. We place some weight on them to arrive at a utility decisions of our choice. And it is the choice of, we model the choice of swerve as the net utility value that we feel about the choice of swerve as the value that determines whether or not we're going to choose that option. Also, we mentioned the hierarchy of individual moral values and group norm. So, so if you're a fan of Bayesian statistical model, a hierarchical model is a very familiar territory for you guys. So we characterize an individual moral values as a noisy version centered around the group norm, the WG, and it was also parameterized by the covariance matrix. And what that covariance matrix captures is what's also, I think is also interesting, is the relationship between the abstract dimensions. So you would imagine that a society that values little babies, infants, would also highly value pregnancy or motherhood as a concept as well. So so the covariance matrix also captures this kind of relationship between concepts. So this is the full model, and I'm not going to dwell on the details of the model, but basically there are 2 hierarchies here. One hierarchy is from the concrete, the character features to the abstract features, and then from the group norms to the individual norm values. So then we took the We took about 99 Danish individuals who participated in the Moral Machine, and then we inferred the group norms of the Danish people. And here's what we found. It looks pretty intuitive, and it captures many of the intuitions we have about people's biases. And if anything, this tells us, we probably should not be using crowdsourced data to build ethical AIs, right? Right? So the whole point of Moral Machine, again, I think Edmund already mentioned this yesterday, is not that we want to build AI machines with this data. Rather, we want to study and understand how does the human mind evaluate moral dilemmas, right? I just wanted to put that out there. So there's also some individuals who by the way, I'm not knocking on Denmark. I mean, this is a consistent pattern across almost all cultures of discrimination against the elderly. So here's also, we capture the individual's weights, or the biases. And given those biases, we can then predict unseen moral dilemmas and what people would choose. So looking at this new moral dilemma, with the weights of one single Danish individual, we're able to predict that the person would choose the left-hand side by 98%. And indeed, we confirm that they do, right? And because of the time, I'm not going to go into details of the benchmarks, but we show that consistently our model predicts human decisions and moral decision-making in number of different training data size. And when I say training data and prediction here, it's not that we're trying to perform a machine learning task, we're trying to accurately predict people's results. Rather, our goal is to validate our model. So higher our accuracy is just simply a way of validating that our model is capturing human cognition in the correct way. One more evidence to suggest that our model is capturing the human processes accurately is the uncertainty of decision and the response time. So along the x-axis, the farther away you are from 0 to 0.5, these are the easier, more certain decisions. Closer we are to 0.05, these are decisions that are very ambiguous. Our model believes that person could choose left or right, it could go either way. And what we find is that the reaction time for those closer to 0 in this x-axis are generally, people take a longer time to process and come to a decision. So what this shows us is that perhaps our model is accurately saying that when people are faced with ambiguous decisions, they just simply take longer time to process and arrive at a decision. So our future work is tackling models beyond utilitarian perspective of morality. So what would a computational model of deontological, Aristotelian, or contractualism look like? And how do these, on what kind of moral dilemmas would these work better in capturing the human intuition of morality? And data beyond trolley problems, I think that trolley problems have been studied to death, and also prisoner's dilemma or public goods games as a model of moral dilemmas, I think that has been studied quite intensively, and I'd love to move beyond those to the real world that incorporates real world senses. So I don't know though, I don't know where we could get this data. I mean, achievements in machine learning have been preceded by large scale human labeled data sets. So where do we get this for ethics? I think that's an interesting question. So if you have any suggestions, please throw them out there later.
Okay.
Thank you very much.
Thank you. Okay, any question? Maybe people can learn so that we are fair and not biased.
Hi, this is for Richard. So just clarification question, were the features of your hierarchy learned or encoded? And then my actual question is, when you were predicting new scenarios, did you check kind of not only predicting new scenarios, but how far from the learning distribution could you predict those scenarios, meaning those abstractions, how powerful they were, and how different methods perform in actually extrapolating far from what they have learned before?
Yeah, so unfortunately, we did not, the matrix that you saw of the abstraction, we did not learn that. So that could be another work that that we could consider using some sort of like non-parametric Bayesian method to capture that matrix. But at the same time, if you use non-parametric Bayesian method, you lose interpretability. You don't know what those features mean. So it's a trade-off. We did several iterations on that matrix and what would work best, and we just sort of settled on that, and we decided to leave inference on the matrix for the future work. Yeah.
Okay, thanks.
Hi, when will Jill Watson be available for my classes?
Yeah, we're still a little protective of her because she's a baby yet, but we're hoping someday she'll get to go out and be a little more in the world.
Yeah. So 2 comments. So the one about the limits of ethical robots. So of course one cannot program robots sort of to in the absence of any context of relationships. So in the first part of your talk, the first robot was a team with the human, right? So if you're a teammate, you want to protect the human and you want to do whatever, like you would be with a friend. The other one was an adversarial one. So what I'm trying to say here, and I agree with your conclusions at the end, of course, it's society that is going to imbue these things, but also we need to think about, from the technical point of view, which is a very difficult challenge, of how to represent and reason about these different contexts that may change. So every person has different roles, as a friend to one person and as a competitor to another and so on, and how do we do that, right? Which is an open AI problem. And the other thing for the MIT gentleman is this thing is data correlations and so on. These ambiguous situations are in investment decisions, in all kinds of decisions of humans, not just in ethical decisions. So these techniques, regression and correlations and Bayesian things, have been tried on other data, right? And so this is just a comment. Thank you.
Great set of talks. Thank you so much. This is first for Dieter, but in a broader question for the panel. I wondered if you could say a little bit more about governance and what you had in mind, because what we've heard yesterday and the day before actually is that either AI changes too quickly to govern or regulate, we can't define it, and therefore it's ungovernable. We've heard a number of reasons why it's not governable, and but I agree. I personally agree with you. We need some governance. So I wondered if you guys could speak to that question.
So I don't know whether I'm a very good person to talk about how this should be done. I mean, the only thing we want to make is your point that it should be done. It's a kind of a thought experiment to drive the point home. But I don't think I would be a very good person to think about it, because that's just not where my strength is. Yeah.
Hi. For the example of the pregnancy question is a really, really great example. I was wondering if you could talk about, have you done anything, or do you have any ideas about how to systematically identify situations like that in your process, or perhaps data-driven dialogue systems? Maybe you've thought about that question.
In our particular case, we have someone who's assigned to go through the semester looking at every post that it responds to and every post that it doesn't respond to but possibly should have, so that we can look at, okay, like, why did it miss this one, or why did it think that this was about a completely different topic? So we're taking advantage of the fact that we can put a master's student on it and say, like, come back at the report every week on what this thing has been doing. If we were on a much larger data scale, we wouldn't be able to do that, but fortunately we're able to monitor her constantly.
From the data-driven dialogue side, we have difficulty identifying those cases where something's missing. But what the perspective that we're looking at it from is identifying, automatically identifying biases. So we're actually trying to gather more data sets and things like that to identify different sorts of biases and the computational models that can predict whether something like an utterance is biased in some way. Because we do want to scale up, so we're trying to find computational models that can kind of model those types of things, which is obviously very difficult.
About 5 years ago, the EPSRC in the UK came out with a set of principles for robotics. And one of those was that robots should never deceive people about the nature of their being robots. Now, you made an argument that there was a situation where it would be pedagogically useful for a particular class to do this deception. But arguably, shouldn't a larger scale social norm like the EPSRC principles of robotics overrule that? Part of what we look to ethics and social norms for is situations where the greater good is actually served by making sure that robots are always detectable by as robots.
That's understandable, and I think you could make the argument very easily either way. Our feeling is that partly because this is a class that consists entirely of people who want to go out and build this kind of bot, we're saying, okay, here's a chance for you to have the experience of having this interaction and trying to feel out how it works and being on the user side. And so we actively, throughout the semester, have them have conversations among each other and discussion prompts and writing assignments where we talk about this and try to equip them to make decisions down the line. But it's definitely one where we could have gone either way and made a real argument that it was okay to do that.
Hi, thank you very much for your papers. One comment and one question. I really like the first paper because of the way in which you make transparency and humility around the development of language. I mean, you've really foregrounded that, and I appreciate it. And I wonder if it may be possible to develop chatbots with kind of a content warning or something saying that this is in development, this is a bot, and please kind of tell us how we can improve it. But the real problem is like the training data sets. I mean, most people look to the cesspit that is social media to do this. And I'm curious about what would it look like if we tried to train chatbots on data sets like, off the top of my head, something like young adult fiction or children's TV or like data sets that actually come with a lot of filters and controls. And I mean, I'm actually really curious about what it would look like to do that rather than just go to something which is very easy and that's just there, like Twitter, which is the worst possible thing anyone can do. So that's, I mean, I'm not a computer scientist, so I'm actually really curious about what it would look like to do that because there's a vast amount of that in probably every language that we know. So, thanks.
I think what we're doing is almost pretty close to what we were talking about because we're using the data that's coming in as part of a class. So it consists entirely of things that people are willing to say to their professor, which is a little better than what we're willing to say on Twitter, since this is a person who has your grade in his hands.
I have a question for Richard. It looks like you built your AI machine based on the learning method. It's very, it really corresponds to applied ethics in ethics or in philosophy, whereas there is another way to think about the moral dilemmas, like what people do in analytical ethics. They, starting from axioms, the definitions, they derive contradictions of like a bunch of moral principles. I was wondering, is there any, I know that in AI there is a way, like a logical-based way to construct AI. I was wondering what is your thoughts about to build a hybrid model, a hybrid AI?
Yeah, so if we're talking about principles and rule-based ethical decision-making, I think those kind of naturally might be more applicable in that kind of perspective of moral decision making. I'm not too familiar with symbolic AI. I think that's a very interesting field. So yeah, I'll just leave it at that. I think that there's a lot of interesting kind of opportunities if combining machine learning with symbolic AI and in that space.
Okay, so let's thank all the speakers again, and we start with the next session. Thank you. Okay, I'd like all the speakers of the next session to come up. And prepare. Okay, this session is as an overall topic of transparency as social good. So the first talk will be on designing non-greedy reinforcement learning agents with diminishing reward shaping. Yeah, go
Thank
ahead.
you. So good morning, everybody. So my name is Shodarin, and we are from National Taiwan University, and today we are going to talk about how to design a non-greedy reinforcement learning agent using diminishing reward shaping. So this is joint work with my student, Fan Yunsun, Yan-Yu Zhang, and Yuehua Wu. So I do realize like we are the only team from Asia to speak in this conference. First, our scenario is that, so we are tackling a problem in multi-agent reinforcement learning, assuming agents have different capability. So one particular problem we are interested in is that in this kind of scenario, the stronger agent will actually dominate resources and leaving the weaker one starving. Okay. So our goal is to prevent such a situation to happen. And the solution is simple. So we are trying to see if we can make the stronger one less greedy. Okay. So the key idea here we adapt is to use the concept of a diminishing marginal utility borrowed from the economics. So here in our scenario, we assume each agent actually maintains some sort of internal pseudo reward. And so those pseudo reward actually doesn't aggregate linearly with the true reward. Okay, so and instead it has the property of this diminishing marginal utility, and means that those additional resources collected in the short period of time will receive reduced or discount reward. So we actually represent the idea use this figure. So on the x-axis, it represents the number of resources. Let me see, number of resources that's correct recently. And in the y-axis, it represents the pseudo reward I mentioned for any newly collected resource. So this photo actually shows that the more resources that have been collected in the short amount of time, it will lead to a discount on the reward on the resource in the next time stamp. How do we realize it in a reinforcement learning agent? So we actually modify the concept of reward shaping and proposed by Angelin and others. So in the original reward shaping, so the shaped reward is indeed the summation of the original reward plus some sort of hidden reward. And in our realization, we add one more state variable into account, which represents how many resources have been collected recently. And we are using this to determine what we call the diminishing factor F here. Okay, so in our reward shaping function, the pseudo reward will be the original reward multiplies this discounted factor. And we have actually tried 3 different discounting functions, and one is the exponential decay, the other is a step function, means that after certain reward have been collected, the additional one will get 0 reward. And we also try the negative step function, means that additional rewards will even receive negative impact. So here is an example, assuming we have this time window of 3 stems. And so in the first slot, we have already received 2 apples, and which lead to a discount of 0.7 on the next reward. And in the next time slot, when we already got 3 apples, they will get even smaller discount factor as 0.5. So what's the benefit of the solution? So first, the most important, we want to make sure the agent will act non-greedily. So it means that they are less motivated to obtain consecutive rewards. And also we want to avoid the so-called homogeneous inequality. So in our framework, everybody is implementing this diminishing reward, means that stronger agent can still obtain more resources, and this non-greediness only happens when there are sufficient amount of resource. And this framework, different from the previous work, we don't require the global observability of the other agents' status about how many rewards or how many resources they have already obtained. And this is cost-effective and simple and easy to implement, and it's universal, can be applied to all kinds of reinforcement learning algorithms. And we did 2 experiments. The first is a gathering game, and there are multiple agents chasing, collecting multiple resources. And the second experiment is the hunter prey, which we have only 1 prey at a time for the agents to chase. And we are implementing using the grid world with typical setup. So we actually have an experiment trying 3 different diminishing function, as I mentioned previously. So the black one represents the original case, which the diminishing factor wasn't implemented. And the red, green, and blue ones are the 3 different functions for diminution. And for the 2-player game, we realized that it seems the mechanism actually allows the weaker agent to collect more resources than it was in the original setup. And for the 2-player hunter game, which there is only 1 resource, and the effect of this diminishing factor is not as apparent as the previous example, because right now the resource is more scarce, so we don't expect the stronger one to sacrifice too much for the weaker one. And to further test the homogeneous equality, the property of non-homogeneous equality, we have another experiment. We adjust the spawn rate of the apples in the first experiment. So, for example, in the low spawn rate, 3, so this means that we have very scarce resources for the agent to pursue. And we realized that implementing this diminishing reward doesn't actually affect the total amount of resources collected by either type of agent. So the black one is the original DQN, and the white one is the one with diminishing shaping. And so it seems like both scenarios, we get a similar amount of resources for stronger and weaker agent. But when we have a sufficient amount of resources, meaning that the spawn rate is higher as 12, and the original DQN actually get a very large gap between the stronger one and the weaker one. But after implementing this diminishing factor, we realized that the stronger one has the less motivation to collect additional resource, which lead to a more balanced resource collections for both type of agents. Okay, so finally, there are still several open questions we left to be resolved in the future. And first, so during our poster section yesterday, Professor Richard Freeman actually raised a very penetrating question. So it seems to be a useful framework to implement, but how can we enforce the implementation of such idea in every agent? Because right now, people still implementing their own agent. And so if that means like, if somebody else is implementing this diminishing reward into their agent and you don't, then you will get some advantage. And so this would really cause some problem in the real world, in practice, how to apply this kind of idea. And the second question is that we do realize that if we want to enforce equality, like implementing this kind of mechanism, it will reduce the overall productivity. And how can we actually guarantee the productivity without guarantee the equality without sacrificing too much productivity? That's still an open question. And also, we are working on the theory on the convergence of the diminishing reward, in particular if there are multiple and many agents, and this could be a potential problem. Okay. And finally, just make an advertisement. There's another relevant work for us and about how to learn universal ethic behavior without large amount of label data will be presented in AAAI in 2 days. Thank you.
Okay. Keep your questions for later. So the next speaker is Katia Sikara. She will talk about transparency and explanation in deep reinforcement learning neural networks. And this is one of the 2 best papers.
Tried it in the morning, and it worked. Huh? Function F? More time? Here?
I think you have to press like window egg or something. What if you do like either you drag it over or you do
I think one more time probably.
Now it should work.
oh then I should
Okay, there you go. Magical technology. Yeah. So, so we are here today to discuss about the transparency and explanation in deep reinforcement learning networks. Thank you for the invitation. And this is joint work, as you see, with a lot of people from some of my students at CMU, some of my former students, and Professor Lewis and Huao Li from the University of Pittsburgh. So as a background, we've seen a lot of the very interesting results in Atari games using reinforcement learning, deep neural networks. And these games achieve, the neural networks in these games achieve a phenomenal performance. And these are control games. They are people play the game, and then the neural networks collect a lot of data, because for every 20-minute play, you can collect a lot of images. So these algorithms, of course, look at the images. So the image data collection is very easy. It's relatively painless. And they work on many millions of images to learn the controls in terms of how to achieve good performance. However, as the current state of the art is, these networks are very opaque. We do not understand why they take the decisions that they take. And so what we would like to do is make them more transparent. And this transparency, of course, would help various stakeholders, not only the users of this technology, but also the developers of this technology, because presumably they will be able to understand why is this algorithm wrong, should I have more data, and so on. But also it could help for if these technologies are used and something happens, then they could help investigators and so on find out what happened, because then there would be some transparency into the thinking of these algorithms. And so we would like to do that and have them be transparent and also explain their behaviors. And What's happening here? This is very strange. Okay. Okay. So here's a background example. So this is the Pac-Man game. And in this situation, the Pac-Man is the yellow dot there, the yellow thing, and the ghost is the red little icon at the bottom. And so if we see that in the next image, the Pac-Man goes to the right, then there are two possible explanations. Why did the Pac-Man go to the right? Maybe to eat the dots or to avoid the Pac-Man, to avoid the ghost. And of course, it could go up to avoid the ghost and so on. So what would be the neural network's explanation? So when the neural network plays the game, what if the Pac-Man goes to the up north, for example, we would like to say that the Pac-Man went up to avoid the ghost. Okay. I hope all of you have some idea about the Pac-Man. The Pac-Man is this yellow little icon at the top there, and it likes to eat pellets, so it gets points for the pellets that it eats. And of course, if it is next to a ghost, the ghost is going to eat him, and so of course he gets minus whatever how many points. And there are things that appear, like the cherry, which is, the cherry is this red thing there, up on the northwest of the Pac-Man, and the cherry appears if the Pac-Man is able to eat the cherry. Pac-Man gets a lot of points, and also at that point, it has superpowers, and then it can eat ghosts. So there is also a random element, because the cherry appears randomly and other pellets, super pellets, appear randomly and disappear randomly and so on and so forth. So it's not really a deterministic game. So it's a very interesting game. And so it's very difficult for people to play and become really, really very good at this game. Okay. So what we would like to do is, as we said, to be transparent on that. So previous work on pixel saliency try to look at why neural networks do particular classifications of images. And so they took derivatives from particular states, and the idea here of calculating the partial derivative is that the magnitude of the derivative indicates which pixels need to be changed the least in order to score the most. So in other words, such pixels correspond to object locations in the image. Okay? But the visualization that you see, if we do that for the Pac-Man game, is the visualization in the gray to the right, and is not very intelligible, as you can see, because you cannot see which is the Pac-Man, which is the ghost, and so on and so forth. All you see are these very, very various pixels there. And so our idea was to introduce objects. So how can we, instead of having this lock, stock, and barrel kind of neural network where it just gets the image and it just looks at pixels, we said, okay, it would, of course, be obvious or easy enough to actually recognize objects in the image. And so what we did, so what you see here is the network and the neural network architectures with all the different layers and so on. But the idea here is that we have an extra layer that does the object recognition. We have different channels. We encode the objects in the pixels. And we say, okay, what are the objects in the image? And so now what we can do is, similarly to pixel saliency maps, what we want to do is have object saliency maps. In other words, what is the valence, what is the saliency of the presence or absence of particular objects in the map with respect to the rewards that the algorithm gets, right? So the underlying learning here is that the algorithms, the neural net algorithm, learns a reward function. It's so-called reinforcement learning. So it learns a reward function, which is basically the discounted reward that I'm going to get if I do A action or B action. So over the overall horizon of the play, if I take a decision now, what would be my reward at the end of the thing? Okay. So the point is that we want to see what is the valence, what is the relevance of particular presence or absence of objects in the image, because that presumably would explain why one would make particular decision over another. And so what we do with respect to that, we say for each object found in some state S, we mask the object with background color, so to form a new state, okay, as if the object had not appeared in the new state. And then we take the difference, we could take the ratio, for example, of the pretend new state when the object is not there versus the reward that we get in the next state when the object was not there versus what we would get if the object were there. And so obviously what you are going to get is that if the object is a good object, that means it helps the Pac-Man get a better reward, then this reward would be positive. I mean, the difference would be positive, otherwise the difference would be negative. In other words, if I add the object, that means I get higher reward. If I subtract it, I get low reward, okay? And so what we get then is what you see in the far right is what we call object saliency maps, and here you see much clearer what is going on. And so the Pac-Man is the dark black on the gray background, and then what you see in terms of the little, what it pays attention to the dots on the high level, I mean the higher thing, the ones that are there with the black. The two white and gray are sort of the Pac-Man at the end. Unfortunately, you know, in the Pac-Man game they have those, but we disregard those. So what the neural network now pays attention to are the 4 pellets at the right and the northeast. Okay. And so then we said, okay, this is great. We can do that mathematically. But now what we want to also see is, are these visualizations useful to humans? And let's do some experiments, not only useful in terms of differentiating scenes, but also in terms of being able to predict the next action. So what we did is we did this experiment with 40 participants from the University of Pittsburgh area. None of them had previous knowledge, so the design consists of 2 tasks. Is the matching task, where the people were given a video, a short video of Pac-Man, and then they were given this object saliency versus unaided, and then they were asking, okay, do you match? Is this sequence, does this match what this object saliency says? Or it doesn't match. And so it was a balanced. 10 trials contained wrong. That means the video and the object saliency did not match. The object saliency did not match what the video was showing, and the others did match, but they were, of course, randomly distributed. And the second task was prediction. So if you see these, I'll explain that. So the matching task, as I said, video clips of Pac-Man game generated by ODQN. And so the 3 frames, as you see from the saliency map, are shown. And then they say, okay, do these 3 match what you've seen in the video? And if you said match, then you were asked also to explain why. And if you said not match, okay. Yeah. And so in terms of the prediction task, it was the same. There were 2 conditions. The people were trying to predict from the scenes, from the screenshots themselves, and the others to predict having seen the object saliency maps. And so what we found is that for the matching task, there was discriminating ability. People were able to discriminate. For the prediction task, it's interesting that there was no significant difference between showing them the real thing, in other words, the scenes, and showing them the object saliency. And so in terms of the results then, the discussion, you will see we have a poster. So the point is that the object saliency maps are then comprehensible and of equal value to people versus the actual screenshots. And these are, of course, pilot experiments. And in future work, we want to understand the practical value of these for more complex environments and situations where there are abnormal behaviors and so on. Thank you.
So the next talk, yeah, is about partially generative neural network for gang crime classification with partial information. How Chan will give the talk, right?
Yeah,
right?
that's true.
Okay.
Yeah, we'll probably have to do something. Okay. Can you guys hear me? Can you guys hear me? Or should I go near the mic? Okay. All right. Hi. Well, something happened. Yeah, okay. Hi, my name is Hao Chan. Today, I'm going to talk about partially generative neural networks for gang crime classification with partial informations. This is a drawing work with Song Yu Song, Phoebe Villanos, Melinton Bay, Yan Lu at USC, Jeff Brandingham, and Georgia Leap at UCLA. And this is some of the work I did as a summer fellow at the USC Center for Artificial Intelligence in Society. Currently, I'm a postdoc at Harvard. So there are over 1 million crimes in the US each year. Roughly 16K of them are homicide. Roughly 764 of them are aggregated assault. And roughly 327K of them are robberies. In fact, a large portion or even some portion of them are related to gangs. Even in LA alone, there are roughly 50% of the homicides are gang related. So given these data, one of the questions that we are interested in is to classifying whether a particular crime is gang related or not. One major benefit of studying these questions is allow us to develop some sort of real-time systems to deal with gang violences. That is, we want to send the right police unit to the right locations for the right tasks. But there's a major problems in the current systems because the current time classification process is labor and time intensive. What I mean by labor intensive is that all of these works are done manually by some specially trained police officers in the crime units. So they have to went through like hours and hours of training and in order for them to become an expert in classifying crimes. On the other hand, even without these labor problems, we still have this time problem of gathering information. So in order to classify the crimes, the police officer has to go there to collect all the information about the crimes. So one of the main goal here in this work is to develop a more automatic systems for classifying gang-related crimes with only partial information. So one question you might be asking is, what kind of partial information we have in the systems? Well, there's two types of features in the crime records. One of them is something that's easy to obtain. That is, once the crime is reported, that's some information we can get from somebody, such as the premise of the crime, the point of entry, the location of the crime, and the street names and other information about the crimes. On the other hand, there's some information that's very hard to obtain, such as the victims or the suspect or the narrative of the crime, the description of the crimes. So one challenge, so therefore, obviously you can see that the easy types are pretty easy to get, while the hard type is hard to get for newer crimes. So one thing we're gonna emphasize here is that can we leverage the existing crimes data that contain both the easy and the hard features to help us in these type of protection tasks. So that brings us this approach in which we want to build this module that takes in the easy inputs such as the premise, the point of the entry, the location of the crime, and then street name, and then hopefully we can split out the narrative, some hard information such as narrative of the crimes. And jointly together, we can make some predictions. So without going into too much detail, this is the deep neural networks that we use for predictions. And together with this autoencoder for generating the missing feature that we have. So I'm not going into too much detail because I don't think I will have too much time. But if you're interested in it, look at the paper and you can talk to us after the talk. So just to tell you some of the experiment we did to evaluate the effectiveness of our methods of classifiers, we used the LAPD crime data set. These are the data set ranging from 2014 to 2016, and we are interested in these type of crime, the aggregated assault, robberies, homicides. So roughly 17% of them are aggregated assault, roughly 13% of them are robberies, and as I said, more than 50% or close to 60% of them are homicide related. So giving these data set, these are the features that we look at. The first one is this gang, let me use a pointer. So the first one is the gang territory. The gang territory, which is the territory of the crime happens. And we also look at narrative, which is the description of the crime. Premise, which is the premise of the crime. The primary weapon that used in the crime, and the number of suspects. As I said earlier, some of the features have different categories. For instance, some of them could be categoricals. For those that are categoricals, we map it into some sort of encoding that allows us to train the classifiers that we have. And for those that are text information, we use Vir2 vector embeddings in order to turn into something that's trainable. The easy feature here is the gang territory, which we can easily look up, the premise, the weapons, and the suspects. But the thing is that the narrative is kind of hard to get, so this is something that we assume that we might not have at the time of testing of the crime. So just to give you some intuition what the narrative looks like, this is the actual thing that police write down, or I guess they input in the data set that we have. So here we have something like suspect 1 and suspect 2 became involved in an argument with multiple victims. Suspect 2 swung at victim with a bat, and then suspect is arrested, and they're claimed that they're gang members. Right, so this is the data that we have. Just to summing up, let me tell you the classification performance using the area under curve ROC. So each column here represent a particular classifiers. Each row here denotes the year of the data that we use. So the idea is that we we train on the years of the data set, and we test it on the whole data set that we have for the same year. So the last column is our methods, partially generative neural networks. And as you can see here, it sort of outperforms all other basic heuristics that we look at, including basic logistic regression, SVM, decision tree, neural networks, and the discriminative model version of our network. And here I'm showing you the area under the ROC curve, which the x-axis the false positive rate and the y-axis true positive rate. Our methods are classified in red, and you can see it's above all the line, indicating is the best classifier we have currently. So clearly, our partially generative model, PGNN, outperforms our classifiers. So let me just conclude by doing some little bit of advertisements for the groups. So the USC Center for Artificial Intelligence is looking for postdoc and summer fellow, and these are some of the projects they're interested in currently: AI for cybersecurity, prioritization for homeless youth housing. There's many other. If you go to that website, you can see a bunch of interesting projects they're working on. And you can also contact Milene Tembe over there, and Eric Rice, who's our co-directors of the centers. And this is the picture from Last Fellow. As you can see, I'm in the middle. Not my favorite picture, but it's highlighting me there. But that's it. Thanks.
Okay, so the last talk of this session is about Purple Feed, identifying high consensus news posts on social media.
So I'm going to introduce myself while I'm putting this on, since we have little time. So I'm Juhi Kulshresht, and the work I'll be presenting today is joint work with my colleagues at the Max Planck Institute, at IIT Kharagpur in India, UFMG Brazil, and University of Cambridge. So it's no secret that people are relying on social media platforms like Facebook and Twitter to get news and information about the society around them. And there are a large variety of news sources which exist on these social media platforms that also span a whole spectrum of political ideologies. So in our work, we focus on US political scenario, which predominantly has two ideological subgroups, Republicans, the red group, and Democrats, the blue group. So even though there exist these varied news sources on social media platforms, users largely limit themselves to stories which reinforce their pre-existing views. So with this selective exposure, red users read red news and blue users read blue news. And this can lead to politically fragmented society. Moreover, often this fragmentation is amplified by the social media platform providers themselves, because they recognize users' preferences and then start recommending more red news to red users and blue news to blue users. And while this approach is great for recommending consumer products, it's not the best idea for recommending news. And the main reason is that it can really limit users' exposure to differing perspectives, which can lead to segregation in information consumption, and which in turn may lead to increase in societal polarization. And there has been a lot said about this recently in the media also. So to combat the polarization, a number of systems have been proposed which promote diversity by deliberately exposing users to different points of views. So this could be done by showing red news to blue users and blue news to red users, or just showing both sides of the news to both sets of users. And the main aim here is to nudge the users to read perspectives which are different from their own. However, in practice, such systems have had limited success because most users either ignore or reject disagreeable points of views. In fact, some research in psychology has also shown that confronting users with the most radical posts from the opposite ideological side may even increase the polarization by encouraging users to retreat to an even more entrenched view of their initial position. So we propose a complementary approach of identifying and highlighting news posts which are likely to evoke similar reactions from readers, irrespective of their political leanings. And we define these purple news posts to be those with high consensus. And these purple news posts can be recommended to both red and blue users, evoking a more unified response across the society, which hopefully might lead to lower segregation in information consumption and might also encourage greater understanding and cohesion amongst the people. So let us take a look at how we operationalize consensus for a news post. As I mentioned, we consider a post to have high consensus if there is a general agreement in readers' reactions to it, irrespective of their own political leanings. So for a given news post, we measure the reaction of Democrats and Republicans, and this we measure as whether they agree or disagree with the content of a news post. And then we compute the consensus as shown here, where the numerators are just the number of Democrats or Republicans who are disagreeing, and the denominators are the total number of Democrats and Republicans. And this implicitly takes into account also the fraction of readers who had neutral or favorable reaction to it. So doing so, we collected reactions of Democrats and Republicans via Amazon Mechanical Turk surveys. We showed every news post in our data set to AMT workers from the US and asked them for their reaction. And we also collected their political leanings at the end of the survey to be able to identify them into one of the two ideological subgroups. And then using equal number of Democrats and Republicans, we could generate these consensus values, and that constituted our ground truth data set. Just to give you an idea, here I'm showing you examples of blue, red, and purple news posts about FBI Director James Comey's dismissal by President Trump. I would like to point out here that while we do perform a preliminary empirical study of high consensus news posts on social media, we do still require an in-depth and larger scale study to understand the properties of these two types of news posts, high consensus and low consensus. And even more importantly, in the future, we're planning to do a user study where we try to understand how these impact the readers. Next, I would like to briefly describe how we automated the identification of low and high consensus news posts. So prior work on classification and prediction tasks on social media posts has mostly used two broad categories of features, publisher-based and content-based. We propose a novel class of features, which we call the audience-leaning-based features, for our consensus identification task. I don't have the time to describe in detail these audience-leaning-based features, but I'd like to give you an intuition using some example news posts. So here I'm showing you a news post by Reuters, which has been identified to be high consensus by the AMT workers. And as you can imagine, each news post has three kinds of audiences. So one is the followers of the source, and then there are the retweeters, as well as the repliers to this news post. And here in the diagram on the x-axis, I'm showing the political leaning, which goes from -1, indicating Republican leaning, to +1, indicating Democratic leaning. And for this particular high consensus news post, we see that the distributions, the political leaning distributions for these three audiences are quite similar. Whereas this other post that I'm showing you, which is about Michelle Obama criticizing Trump's school lunch policy, this has been identified as a low consensus post in our data set. And here, if you notice the retweeter distribution shown in green and the reply distribution shown in red, they are quite separated out. The retweeters are leaning more towards Democrats, whereas the repliers are leaning more towards the Republicans. And we see this kind of separation for low consensus posts in most of these posts, most of the posts in our data set. So the intuition is that the retweeters typically tend to be those users who actually agree or support the news post, whereas the repliers also contain users who are actually opposing or debating the post. And this is what our features are based upon.
It looked like on the slide on the right that all the followers were leaning Democrat. Am I reading that correct?
Yes, but that's also because Twitter is predominantly, like, it has a skew towards Democrats in general also. We can discuss this offline. I've done a lot more work on this, yeah. And then we performed our experiments, and we found that our audience-leaning-based features were outperforming the other publisher and content-based features for our task of consensus identification. So I would just like to end with a brief overview of what else you can find in the paper. You can find the details of how we conducted the AMT surveys to construct the ground truth. You can also see a short empirical study of the consensus of news posts on social media. And finally, you can see the details of our audience-leaning-based features and their experimental evaluation. And of course, if you're interested, I'd be happy to talk to you about those too. Thank you.
Okay, anybody wants to ask questions? Can you line up so that we can?
One of the things that sort of bothered me through the last couple of days is this false equivalency problem. So if we're going to debias information sources, and that's presented as sort of a positive good, and we also are going to have ethics and things that we believe are right and wrong, aren't those in conflict? So for instance, if we were to debias postings on genocide or something, is that an appropriate thing to do? I would direct it here for the news debiasing, but I think it applies more generally.
So in fact, we do not debias the news. So the reaction of the readers has to be similar. You could have a negative reaction or you could have a positive reaction. And I would presume if it's a genocide thing, most people would have a negative reaction to that. So that would still be considered as high consensus.
I think my question is along a similar line. The presentations gave the impression that the number of blue-leaning and right-leaning people was approximately equal, whereas there's been a significant trend. So the presentation may have skewed the proportion of change among those who had previously been undecided or had changed their leaning. Also, the prevalence of whether one side of the news is considered more fact-based or the posts are considered more fact-based or more based on alternative facts was not clearly shown by this presentation.
Yeah, sure. So I completely agree the distribution is not equal, but for generating a data set, we took equal number of people from both sides to respond to each news post. And about the second thing about whether it's factual or not, I completely agree with you, and that's exactly what we want to do in the next study. We want to do a larger empirical study to understand what are the differences in the characteristics of these like blue, red, and purple posts. And I do believe there are some things about alternative facts would come up, but I don't have the answer as yet.
My question is about the predictive policing work. I wonder, sort of given that we know that police records are not necessarily representative of crime, and that what you characterize as sort of the hard information to extract is police narrative reports, which could also be skewed in various ways. I'm wondering, given that we're at an ethics and AI conference, what steps the research team took to think through the impact of the models you were building, because the result of those models is police officers showing up at a crime scene, maybe perhaps more ready to pull their weapon and shoot if they think it's a gang-related crime as opposed to some other related crime. And thinking back to Carol's presentation last night, that addition of people to gang-related databases can have cascading effects on whether they're subject to increased scrutiny later on.
Right. I mean, yeah, I guess it's somewhat subjective, right, in terms of how you write your narrative, right? Like one person might not writing the same way as another person. But I guess from what I know from LAPD is that they do have like a standard procedure on how you write narrative. They could written in a different semantic, but they try to be more consistent with each other. I guess there's a concern about how would you make sure that they are not injecting their own biases into narrative. I guess that's something that we cannot control because we don't have ground truth what the actual thing gonna look like. But the thing is that for crimes such like aggregated assault, homicide, or the robberies, they're from what I know, they're pretty consistent. That's why we select those three to learn from, not the other types of crimes. That's sort of one way of filtering our biases, just looking at data set in which you know that there will be consistency among these police officers. But yeah, I agree, it's a hard problem to handle, right? It's the same thing as labeling, because like when you label whether a crime is gang related or not, then it's very person dependent, right? This holds for all other machine learning labeling tests, because labeling is somewhat subjective things. So that's that. Yeah.
Hey, so other people have addressed some of the things I brought up, I wanted to bring up, so I'm going to be that guy who's like, well, I have a comment instead of a question. First of all, on the predictive policing, I think the question is really relevant, and I think that one way maybe you can think about you're right, I mean, there may be a consistency in the narrative structures and descriptions that are used, but those are themselves a product of acculturation. Mm-hmm. And that maybe one way to get at that would be to run a kind of an analysis of the materials that are used in police training, because there is a fairly consistent body of materials. Mm-hmm. And I think it would be possible to begin to track some of the forms of acculturation and some of the standardization of language and thought patterns that officers are trained into, which would then help give you a lens on those narratives.
Right.
That's a thought.
Okay,
The second thing I want to say is about the final paper, which I really appreciated precisely because I thought what I saw you doing was not making normative value judgments about the papers, but rather thinking, given the disposition of people whom we need to persuade, how do we reach them, and that it was a way of recognizing what makes it possible to get people to begin to listen, and that the question of what are the normative values or the validity of the truth statements that we're passing on, that is actually a later project. So I just wanted to say thank you for that. I thought that was a really, really great framing and a really nice targeted use of AI. So thanks.
Thank you.
Oh, I think it was like comments.
So another one for the crime labeling. Let's say that somehow, some way, we solve every problem that's been brought up so far. We have ground truth, we have 100% confidence in it, and somehow the model has 100% accuracy. You are accurately saying this was a gang-related crime. Is there any concern that this kind of technology would create an undesirable feedback loop where police are responding with greater force to gang-related crimes, and in those neighborhoods, incentivizing them to take a more hardened stance to protect themselves from the police, thereby creating more gang-related crimes, creating harder responses from the police, and destabilizing the community through giving the police asymmetric information?
I mean, that's a valid concern, right? I mean, there's two things I want to bring up. One is that people are hesitant about using machine learning tools directly. They want to use machine learning tools to make a decision together, not just blindly using machine learning, whatever we tell them using machine learning tools, right? The same thing for other projects that we're involved in with the housing community, with the policing community. They don't want to just look at the machine learning tool as the only decision point, right? They want to say, okay, here's some interesting observation, let's analyze a little bit more, and then let's see what we can make out of it, right?
So are you also building AIs to help the communities know when the police are about to raid them?
Well, no, we're not doing that either. I mean, like, I mean, this is some sort of ethical questions that I don't know how to answer because I don't work on the other side of policing, other than helping the police to build a system. So as a researcher, I don't know what's the appropriate answer for that question. But yeah. So.
They go up, who cares as they come down? That's not what they want.
But thanks for the comment, though.
Yeah, so I had, I guess, questions for two of the papers for the predictive policing. I guess I have a higher level question, well, some context as well. Like, I'm curious if you worked, how closely you worked with the police department, and if this is like something they wanted, or if they're like using it. So that's one question. And I guess a higher level question is this useful? Like, to me, it seems, you know, if you hear that there's a gun, then that like makes you respond a certain way. Like, you know, I guess like if they believe that it's gang related, they will respond. They'll be like, I don't know. I guess it seems like it, you know, the response doesn't necessarily depend on, you know, they should be prepared to respond. If there's a gun, they should be aware of that. But I don't know. So I guess I'm curious about the utility of the model.
So okay.
For the purple feed, so I spent a lot of time, for better or worse, on 4chan and 8chan and such, and I'm curious, so I think about, you know, gaming and trolls, and so I'm imagining, like, you know, if I wanted to try to attack this, I might, as an alt-right troll, sign up 100 Democrat-seeming accounts and then say that I like, you know, all these right-wing stories, and then have that sort of show up on like, you know, center or left-leaning people's feeds. I'm curious if you thought about that.
I mean, there are a lot of techniques out there which tackle these kind of Sybil attacks. I would suggest using one of them. I'm not an expert, but I could point you to some papers. And the other thing is that we have like a continuing baseline that we are also monitoring. So this also answers your question, ma'am, that we do take into account that there are different compositions of Democrats and Republicans who are existing, and there may be different distributions of them for different publishers. So we compute per publisher baselines, which are computed periodically to make sure that we are accounting for this change in distributions.
Yes, yeah, okay. So I guess there's two things I need to comment on. The first is that their system is not currently in use. So that's a good thing for some of you. I mean, on the second part, I think you can view what we have as a method of deterrence, right? Not necessarily a way of capturing people, but a way of deterring the gang violence happening in certain area, right? So you might be able to say, okay, now I know that a lot of a lot of places in this area had a lot of gang crimes, right? So you might say, okay, I'm going to send a little bit more policing force in there for that purpose, right? Just deterring gang crime from happening in that particular area. But I mean, I don't know how they would use it because, to be honest, LAPD is kind of quotation. So I don't know, I don't know how they would use the technology. So there's some other project that we have with them, but we hesitant to continue on that project is because we don't know how they're going to use it. And a lot of government agencies not going to tell you how they're going to use the project or the outcome of the projects. So like we don't want, so as a researcher, we don't want them to run up people to arrest. That's not what we want. We want something that could help them to reduce violences. We don't want them to use our technology to round up people, lock them in jail. That's not what we want. So we do, I mean, whatever we do with them, we want to make sure we know how they're gonna use it and at least have them some sort of agreement that like this is limited usage at that type of situation. But yeah.
I just had a quick question about the Purple Feed presentation, which I really enjoyed. The question is about whether some people, the Turkers, might react to the source of the news rather than the content of the news. So there's a choice maybe in how you say, is this from New York Times, is this from something else? I wonder if you looked into that effect on how they would interpret the results.
So in our experiments, we only showed the content of the news, so we did not show the source, but there are other papers which have looked at the influence of the source on people's perceptions. And that's the kind of experiments we want to run to understand how people are actually now reacting to these different kinds of like low consensus and high consensus news, especially if, we did find high consensus news also from sources which are typically not thought to have these kind of like Breitbart or Salon or Slate, which have a fairly clear political ideology. So it would be interesting to see how people react to that.
Well, thanks.
Lunch. Speakers again.